Hello and welcome to Tinkertubes Lab. Today we are continuing with the amplifier project. As you might remember and probably can see here, I have had a power transformer mounted here before. I have removed that now because I ran into some issues regarding the power calculations. As I told you in the last video about this project, I built this basically from scratch. I think it was about 15 years ago now, without any plans, just by gut feeling, and well, obviously that was not ideal. So when I calculated the parts now, I noticed that I had some issues with the power, which was also noticeable because the transformer got pretty hot in normal use. I mean, it still held up for 15 years, so no problem there actually, but still I wanted to make that better. So let's put this to the side for a moment. And I decided to dig around a bit in my stash of stuff, and I found this really nice power transformer from Löwe Opta. It is a, well it's way bigger than the old one, if you compare that. So a lot more power. Oh, also I should switch on the big lights. Aha! We have light. Yeah, this is obviously much bigger, so it won't fit on the old chassis. So I thought today we are taking a look at an idea I had, making basically an external power supply for not only this amplifier but also for potential future amplifiers. Oh, and while I'm at that, I'm also trying out my new microphone. Thanks you at this position to my good friend Rusty for sponsoring this microphone. I really appreciate that. So let's get started with this project. The main idea is we will put this transformer in a 3D printed case, which will have a standard IEC input cord like these. Also it will have a fuse inside and some small simple circuitry, which will be one relay, which looks a bit trashy, but it's pretty new actually. It just looks stained for whatever reason. And also a small standby transformer, because the idea is I want, as this is going to be an external power supply, I will route a wire outside of this, and if I plug it in, I would have an external connector which would have either 300 volts AC or whatever this is outputting 250 volts AC on one pair of pins, which I would like to avoid, so yeah, just for security reasons. So I want to have that switchable, so I could either put a switch inside of this, which I will actually do, but it would be quite dumb to always climb under the desk, switch on this PSU to just switch on the amplifier. So I wanted to have a remote switch kind of situation. This is where this seperate transformer comes into play. So this is powered as soon as this is on, sends out the 12 volts AC through the cord, coming back, switching this relay, which in turn will switch on the big transformer. Yeah, let's see how this build turns out. So let's start with the input side of things. We shall begin with the IEC input jack. Of course, we do not need the ground point on that one, so we can just ignore this for the moment and just try to solder some nice wires onto it. I'm using quite old but still pretty flexible and nice wiring here. This is a silicone isolated wire, so even though it is very, very thin, it is actually rated for quite high voltages. I think if I have that correct, it is rated for almost 1000 volts, but I'm not 100% certain about that. But it will absolutely be enough for mains wiring. Solder that. And let's see where we want to get that into. So from this pin we want to go to the switch, which will be about this length. You always have to adjust later. And from there we just go to the fuse, which I will solder on first, because that one will be a bit hard to reach later. Yeah. Silicone wire. Pretty hard to get the isolation off because it is basically just like a rubber band, so try that again. Ripping it quite violently usually helps. Also, it's always a clever idea to hold your soldering iron just straight above a 3D printed part. It's absolutely not screaming for problems. But so how are we going to solder this one? And there we have it. Switch mounted, power socket mounted, and also the fuse. Looks a bit messy. I should have shortened these wires a tad more, but it will be good enough. So, next station will be to somehow maneuver these wires either up through here, which will obviously not be a problem to mount, or to put them through that hole. I'm not quite sure how I will do it, because from the other side we need this cable coming from inside of here. Got it. So we got that into here, and I think there is still enough room to get these through. Oh, it is good. So next thing would be the I think we should start with the 230 volts connection to 1 the relay and 2 to the little transformer. For that I have prepared these good old solder bus bars, and I melted in 2 little studs to kind of make them fit. And my plan is I want to poke these 2 leads from the bottom through, solder it inside, so that we have 2 connections potentially going to the relay and 2 going to the transformer. So let's just try to do that. That looks nice. So we'll check if we managed to, yes, both are soldered nice. So let's add 2 spacers onto here. I use these plastic standoffs, which have a brass insert on one side and a brass stud on the other side, just to give some spacing from the live side to the isolated sides where the transformers are. So now we need to add the relay. Just let me think for a second. We need 1 wire from the lead coming back to the relay and the other wire from the transformer. For that I would probably use just a diode, so basically the lag of a diode, as this is a DC relay, which should also work with pulsed DC, but we will see that. Worst case, we have to add a little capacitor, which we could do just for good measure, but we will try later. Also, you might see I have bent over 2 pins already. These are the normally closed pins. So when the relay is off, that pin is connected to here and that one to here, and when it switches on, the middle pins connect to the outer pins. So this is where our bigger transformer connects to, and these is where the mains input side will connect to. So, primary side wires connected to the transformer. Now we need to connect these to the input side. Diode installed, and now we should be able to just give it a quick test. For that I should grab the other side of this cable and throw down stuff from all around the lab. Perfect. Try to cut open this insulation a bit. And yes, this is shielded wire. Of course, we do not need or use the shield in this application. We could, but I would have to put it through this gland somehow and connect it to the protective earth, which I could do, which might even be beneficial in some applications, but I did not. Maybe I will do that later, who knows. So let's just get these two, the black and red. And now we could, or should be able to make the the relay click as soon as we connect these. And of course put power in here and add a fuse inside the fuse holder. Let's just grab a fuse then. For example, we have for a test very small one, 125 milliamps. Let's see if I can get that in here somehow. I can. Should be good enough for a test. Now let's grab a appropriate power wire. 1 second please. Power cable acquired. So let's see if that work. So if I fuck something up, maybe, just maybe, I should take a quick measurement and just do like a little sanity check. It's always good when you do this hard stuff to just be super sure. We do not want a squeaker. We just want to see if we accidentally made a short, which we do not seem to have. Let's switch that on. We still do not seem to have anything. This is also not correct. We should have something. Let's try it here. Oh wait, this is a very small transformer. It's probably over range, more than 200 ohms. No. Oh, 2.1 kilo ohms primary. Is that real? Yeah, it is. Okay, cool. Well, okay, this is a, I think it is a 1.2 volt ampere volt ampere transformer, so it is tiny, so we expect a pretty high resistance, and this looks good. So put that aside, and let's see with this very simple circuit we can make the relay work. Put that here, switch that on, and let's listen. I hope you can hear it, if you can hear it. Yeah, it is not really switching as you hear. It's just buzzing. So let's try some things. Also, I noticed that this switch is not illuminated. How nice of it. I actually chose that one especially for the small lamp, which is not lamping. You might be able to not see it as well. See, it's not really making any difference at all. Dang it. But it is still a very nice switch from the feeling. So let's increase that capacitance. So capacitors changed. We have now a 100 microfarad, and let's see. I would say that is switching very well. So let's switch that off again and remove that. We do not want to have our fingers near. 5 wires. This could potentially be hurting quite a bit, so we want to avoid that. Put that away. Put that back. And let's continue. Next, we need to get the big transformer inside of here, connect that to the relay switch side, and then wire the output sides on. So let's get the big transformer here and put that inside. We have to see where we place the wires. These yellow ones are the primary, so let's bend that over a bit here, and these ones, the red and green ones, are the secondary. It is a kinda tight squeeze, yes, but nevertheless it will work. So to fix this, I have some very long M4 screws and these long nut things to screw on top, which will also be the mounting points later on for the connection for the top half of the case. Usually you would put insulation around a metal shaft going through a transformer, but I do not have any thin insulation material for that. I tried using a very thin kind of tape, like Tesa tape, and this was even too thick, so we have to live with the losses that occur, but it will be okay enough. So let's put these through. Maybe put them through first and then try to add the transformer. Also, please note this is the first revision of this plastic case that I designed, so it is far from perfect, but it will work well enough for that. We don't have to make it perfect. So let's try to align this. Ideally without squishing my fingers. Come on. Bit more. Bit more. Go down there. Oh, I'm pinching a secondary there. And we have it seated. Nice. Let's quickly add these bolt nut things to just temporarily fix it. We will tighten these later on. So now we need to connect this bunch of wires up. Pin number 1. Pin number 2 needs new bending, of course. And a new loop. So, connected that back up. One last check. If we did not fuck up again. And here we have our 33 ohms. Nice. So, however, we should keep that here, just in the voltage mode. And maybe have a second meter besides it, just to see what the heater voltage does. Let's put that one here on the high voltage. And let's take 2 new wires. And put these on the low voltage part. Take a good meter. We have voltage, we need 20 volts, and we want AC. Connect that up. Make sure that nothing shorts out. And now we just need to plug that back in the right way around and switch that on. And we have some problem. First, why is the relay switching on already? Oh, because that was touching. Okay, nice. Also, the high voltage is not voltaging high. Why is that? Is it just me? Because that means that I have to disassemble this again. Why? So, let's see. Just measure that. And ohms. Oh wait, did I switch to AC? I am not sure if I did. Try that again. Switch it on. Ah, look at that! 280 volts. Nice! It is rattling a bit. These are the loose plates here. If we press that down, it does not rattle anymore. So we should probably tighten these. Look at that, we can modulate the frequency by tightening the screws. Cool. Yeah, that seems to work. Also the heater voltage is also 7.5 volts without any load. So that is very, very nice. I like that. Now we just need to connect these wires up. Cool. So, for the last steps, we need to mount 2 more of these little terminal strips onto these posts and connect these wires and these to the strips as well as the output wires. So let's just start with that. We put another strip up here and add 2 standoffs as to screw these down. Just quite tight, but works. I just tighten that down quick. Oh, I just noticed that one is smaller, so I could not hide that with this screwdriver. So, does not matter, still works. I think I want to have the high voltage line in the middle, so there is less chance to accidentally touch it. Therefore I bent up these heater voltage lines. Also we unwrap, or do we? We don't actually need to completely unwrap it. We can fold it like that. Maybe. Solder that down. Reposition these wires a bit. Reposition that a bit. Okay. That was part 1. Now we need the heater wires. again we put a terminal strip up here, and now we use just 2 nuts to finish that off. This little mountain of wires, which is again pretty fiddly back here, but we got it. Screw that down, screw that down, and now we take red and orange as well as green and brown, which is probably easier said than done. Let's see, how can we do that most effectively? Holding that down with a tool usually helps. Nice. So let's just connect these up, and I will just solder them right on top. Yep. That worked good. Does not look too pretty, but that should work. So let's remove that. That is strong. That is strong. Holding up good. That is good. That is good. Yeah. All that is left is screwing these down, putting a bit of glue on these rattling metal plates, and then closing it up. I will do that right now. So that is the PSU finished. I noticed a small little hiccup while designing this case. It seems like I have miscalculated the thickness of the transformer, or mismeasured by a millimeter or so, because as you can maybe see, the top lid is bulging a bit outwards. But in my opinion, this is not too big of a problem. I will not reprint the thing for that. Best part is it works. So I connected the multimeter to these output ports on this cable, which will be of course terminated with a nice plug, which will then connect to the amplifier. And I measured it and everything works fine. High voltage appears here, heater voltage appears here. If I open that, it switches off. Perfect. Exactly as we planned. So this is the preparation for the work on the amplifier done. Next video about it will probably be calculating the amplifier itself, or maybe some video about measuring and identifying output transformers and identifying what impedance they are intended to be used with. So, if you're interested in that, I hope to see you again the next time back here at Tinkertubes Lab. Until then, have a nice day.